When we talk about renewable energy, we are really talking about energy that comes from nature and can be used over and over again. Instead of relying on fuels that will eventually run out, renewable energy uses sources like sunlight, wind, moving water, and heat from the earth. What makes renewable energy so important is that it doesn't disappear after we use it. The sun rises every day, the wind keeps blowing, and water continues to flow. Because of this, renewable energy is much more sustainable in the long term. Now, I'm going to talk about the importance of renewable energy. First of all, renewable energy helps reduce environmental damage. Unlike fossil fuels, it produces much less pollution, so it helps keep the air and water cleaner. This is important for human health and for protecting nature. Another reason renewable energy is important is because it provides a sustainable energy supply. Sources like sunlight, wind, water, and will continue to be available in the future, which means we don't need to worry about them running out. This makes renewable energy much more reliable in the long term. Renewable energy also improves energy security. By using local sources, countries do not need to depend too much on imported fuels. This reduces the risk of energy shortages and sudden price increases. Finally, renewable energy supports economic growth. The development of renewable energy creates new jobs in areas such as manufacturing, installation, and maintenance. It also encourages innovation and technological advancement. Overall, renewable energy is important because it protects the environment, ensures a stable energy supply, and supports economic development.
Hello everyone, today I'm going to talk about solar panel. Now let's take a closer look at how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In the solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbor by a strong bond, which keep the electron in place so no current can flow. Here the key. A silicon solar cell uses two different layers of silicon. N-type silicon has extra electron, and P-type silicon has extra spaces of electron called holes. Where two types of silicon are mixed, electron can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The electron is drawn to the N side, while the hole is drawn to the P side. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the P-N junction, they will only go one way. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow to an external circuit, doing electrical work like powering a light bulb, before returning to the conductive aluminum sheet on the back. Solar panels absorb sunlight and convert it into direct current, DC, electricity. Batteries. Batteries store extra electricity produced by the solar panel. The stored energy can be used at night or on a cloudy day, ensuring power supply even when sunlight is not available. Inverter. Since most home appliances use alternative current, AC, the DC electricity from the panel goes to an inverter, which converts it into AC electricity for use in the house. Grid power. When solar production is low, electricity is automatically taken from the grid. If the solar panel produces more electricity than the home needs, the extra power is sent to the electricity grid. It is called net metering. To close, solar panels give us clean energy from the sun. They save electricity, help the environment, and are an important part of our future.
Hydropower or hydroelectric refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water is constantly renewed by the sun. Hydroelectric energy comes from capturing the force of moving water that's in our Earth's river and oceans. We do this by using the movement of the water to spin hydraulic turbines that generate kinetic energy, which is converted to electricity through a generator and then sent to power grid. Most hydropower is generated by dams that store water at a higher elevation and release it through turbines using gravity to generate electricity before returning the water to the river. Hydropower have several benefits. It is a competitive form of electricity even though the initial building cost can be high. It is quite reliable to other renewable options and pairs well with other sources as it can be used as base load power. It also helps for flood control and be reliable water supply for communities. Next, I will talk about wind energy. The basic principle of wind energy is simple. A series of sails or blades mounted around a rudder catch the wind and translate kinetic energy into electrical energy. Traditional windmill use that rotational energy to grind wheat or pump water, but nowadays it turns a generator that creates electricity. This conversion from wind to rotational energy to electricity has defined wind turbines since in the 19th century. Three primary factors that determine just how much energy they can produce: the size and orientation of the blades aerodynamic design, and the amount of wind turning the rotor. First, blade orientation. Wind turbines can be designed with their rotor on a vertical axis or a horizontal axis. Vertical axis can pick up wind coming from any directions, while horizontal designs allow blades to capture the wind full force by tracking wind's direction and turning to face it. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. There are fiberglass and resin layers. These blades are strong enough to operate through rain, lightning, and blistering sunlight. Even with aerodynamic blades, wind turbines can only capture wind if it's in a windy environment. Most turbines are over 100 meters tall. A wind of this height and size can capture a huge amount of wind, generating enough electricity every year to power 1,715 homes. Despite its amazing potential, wind energy still faces challenges. Wind may be free and unlimited fuel, but no matter how large or efficient a turbine is, there's a mathematical limit how much wind it can convert into electricity. Other than that, some people feel turbines disrupt natural scenery. Next, wind energy intermittent availability can make it difficult to integrate into electrical grids. With these challenges, modern wind turbines have made wind energy the most efficient and inexpensive source of electricity. It also provides essential energy for communities around the world, and for many farmers, it helps out them to gain additional income. So next, I will talk about the differences between hydropower and hydroelectricity energy. So hydropower uses flowing or falling water to generate electricity, while wind energy uses moving air to turn turbines. Hydropower is more stable and reliable because water flow can be controlled, especially in dams. Wind energy is less stable since it depends on wind speed. In terms of electricity output, hydropower can produce large amounts of power consistently. Wind energy output varies depending on how strong the wind is. For environmental impact, hydropower can affect aquatic ecosystems, while wind energy has minimal environmental impact.
Today, I will explain the renewable energy full system flow, including the instruments and energy storage. First, energy sources. Renewable energy comes from natural sources such as sunlight, wind, and flowing water, which are measured using instruments like a pyranometer, anemometer, and flow meter. Next, energy conversion. The natural energy is converted into electrical energy by solar panels and turbines, and the output is checked using a multimeter and a power analyzer. After that, power conditioning. The electricity is regulated and stabilized using charge controllers like TVs and inverters while an oscilloscope is used to ensure the voltage waveform is correct. Then, energy storage. Excess electrical energy is stored in batteries for later use, and the battery condition and temperature are monitored using a battery analyzer and a temperature sensor. Next, power distribution. The stored or generated electricity is supplied to homes, industries, or the grid, and energy usage is measured using an energy meter and a current transformer. Finally, monitoring and control. The entire system is continuously monitored and controlled to ensure safe and efficient operation using a data logger and a SCADA system. In conclusion, renewable energy systems efficiently capture natural energy, convert into electricity, store excess energy, and distribute power safely with the help of scientific instruments.
Four benefits. First is environmental, second is economy, third is sustainability and reliability, and lastly, fourth is health and social benefit. First, renewable energy gives major environmental benefits. Unlike fossil fuel, renewable energy sources such as solar and wind do not release harmful gases like carbon dioxide. This helps to reduce air pollution, slow down climate change, and protect natural ecosystem for future generations. Next, renewable energy provides strong economic benefits. Although the initial installation cost may be high, renewable energy reduces long-term electricity costs. It also creates job opportunity in manufacturing, installation, and maintenance, which helps to boost the economy. The third benefit is sustainability and reliability. Renewable energy sources are naturally replenished and will not run out, unlike fossil fuel. With proper technology and energy storage system, renewable energy can provide a stable and reliable power supply for long-term use. Finally, renewable energy improves health and social well-being. By reducing air pollution, it lowers health problems such as asthma and respiratory disease. Clean energy also creates safer and healthier living environment, improving overall quality of life in communities. There are few challenges of renewable energy systems. First, the electricity generation capacity is still not large enough. It's difficult to generate the quantities of electricity compared to traditional forms of energy generations like fossil fuel. This may mean that we need to reduce the amount of energy we use or just build more energy facilities. This also shows that the best way to solve our energy problem may be balance many different power sources. Additionally, unreliable weather can affect the energy supplies of renewable energy. Some days may be windier than others, the sun doesn't shine at night, and drought may occur for periods of time. There can be unpredictable weather events that disrupt the stability. When these sources are unavailable, so is the capacity to make energy from them. Finally, renewable energy requires a huge financial outlay. The current cost of renewable energy technology is also far in excess of the traditional fossil fuel generation. Currently, the cost of renewable energy technologies far exceeds traditional fossil fuel power generations. For future and innovation, renewable energy system can improve in the future through technologies and innovations. First, better energy storage systems such as advanced battery and hydrogen storage allow excess solar and wind energy to be stored and used later, thus making the energy supply more reliable. Next, smart grids with artificial intelligence and Internet of Things technology help manage electricity efficiently and reduce the energy waste.
In addition, solar panel and wind turbines are becoming more efficient while producing more electricity at lower cost. Another important innovation is green hydrogen, which is produced using renewable energy and can be used as a clean fuel for transportation and industry. Finally, hybrid renewable system combine solar, wind, and storage to provide a stable and continuous power supply.
In conclusion, renewable energy is an important solution for our future. It uses natural sources that do not run out and causes less harm to the environment. By switching to renewable energy, we can reduce pollution, protect the earth, and ensure there is enough energy for future generations. As technology improves, renewable energy will continue to grow and become part of our daily lives. Overall, renewable energy helps create a cleaner, safer, and more sustainable world.